All right, so in this video, we're going to talk about continuity, and we'll start with the definition. And the definition we're going to talk about is the idea of continuous, a function being continuous at a point. So we'll say, as the definition, f is continuous at our point x equals c if the limit as x approaches c of f of x equals f of c. Now, this essentially says a handful of things, and so I'm going to kind of break it apart a little bit. The first thing that it says is that f of c must be defined. Right, so f of c, that's the y coordinate when we plug the x value c into the function that comes out. So that point has to be there. The second part says that the limit as x approaches c of f of x must exist. And we've seen limits that don't exist. And so for something to be continuous, we have to have this limit existing, which actually, if we take it a step further, why might a limit not exist? Well, it might not exist because the left-hand limit doesn't equal the right-hand limit. And so what I'll go ahead and I'll say is the limit as x approaches c from the right and the limit as x approaches c from the left must exist and be equal. Okay, so that's part two has an additional component as well. And the third thing just kind of summarizes the definition. It says that the limit is the same as the point. So again, this is your true definition right up here, but kind of explaining it in a few extra steps probably is the easiest way to understand what we're dealing with here. Okay, so for this problem, you can see I've got a pretty elaborate graph up on the screen. We're going to investigate whether or not that function is continuous at 4, 2, 1, and 3. Okay, so let's say that this guy is f of x. Is f of x continuous at 4, 2, 1, and 3? Okay, so we'll take a look at 4. And so to really understand whether or not something is continuous, we have to go back to the definition. I think intuitively most people would see x equals 4 and say, no, that's not continuous. And you're correct, it's not continuous. But why? Which one of the conditions that we discussed is not met? Well, it looks like right off the bat, f of 4 does not exist. There's no point here at 4. This looks like it's an asymptote, so there's no point there. Therefore, the point does not exist. Therefore, can't be continuous there. It's as simple as that. So now, for x equals 2, so now we're looking to see if we are continuous right here. And the definition says that the limit must equal the point. What's the point? Well, f of 2 is 3. All right? So f of 2 equals 3. For it to be continuous, the limit as x approaches 2 of the function should also equal 3. But does it? No. Looks like the limit as we approach 2 and we come in from the left and we come in from the right actually equals 2. So due to the fact that that's not true, right? It's equal to 2. The answer would also be no, not continuous at x equals 2. Okay? So how about x equals 1? Well, for x equals 1, you can see that f of 1 would equal 1. We can also see that the limit as x approaches 1 of the function does not exist. Now, why does it not exist? Well, what is the limit as x approaches 1 from the right? And what is the limit as x approaches 1 from the left? As we approach 1 from the right, you're going to be at 1. And if you approach 1 from the left, you can see we're going to be up here at 3. So because we have that contradiction, you're also not continuous at x equals 1. Okay, so not only being able to answer the question is important, but many times I'll ask, well, why? And so you'll have to give me an explanation similar to what I've done here using that definition. Now, a couple things worth pointing out. These three are discontinuous at those points. This guy right here, this is called an infinite discontinuity. This guy here is called a removable discontinuity. And this one here is called a jump discontinuity. And the removable one you might be familiar with, but having dealt with holes probably in college algebra, the infinite and the jump, both by name, kind of makes sense. So those are just the names. Now, if we look at x equals 3, let's kind of run through the list on this one. Well, what is f of 3? Well, f of 3 looks to be 1. Okay? So f of 3 looks to be 1. And what is the limit as x approaches 3 of the function? In other words, what's the limit from the left and the limit from the right? So as we approach from the right, we're at 1. As we approach from the left, we're at 1. Therefore, 1. Since these two numbers match, therefore, the answer is yes. Our function is continuous at x equals 3. So again, not only are the yeses and nos important here, but I will ask why, and I'm looking for explanations like we've discussed using those the parts of the definition.